Welcome to Living Well. We're so happy that you decided to join us today for a very important topic. Diabetes type 2, treat the root, not the fruit. Our speaker today is Josephine Johnson. She's been with us before, and Josephine is a registered dietitian. She also has a Master's of Science degree, and she has a degree in functional nutrition. So she has an I think it's LDN. And so we're really glad that she's with us today, and she's going to share with us about diabetes. Now, many of us know someone, at least one person that has diabetes, and sometimes people really want to get off their medication or want to be able to manage their diabetes better. Well, you're on the right program today. If you're not a diabetic, but you know someone, this information will benefit both of you. And so I want to remind you that our program is for educational purposes only. We do not assess, diagnose, or treat any conditions. We may use biblical references, research it, personal experiences, but our main purpose is to give you some information on your journey to health and wellness. So Emily and I are very thrilled that you are here today and that you're taking time to learn more about how to care for these bodies, these wonderful bodies, these fearfully made bodies that God has given to us to take care of. And so we want to be good stewards. And that's why we have Living Well on every Sabbath, because we know that this is a perfect time to reset our mindset of how we can care for our mind, our body, and our spirit. Josephine, we are so delighted that you're here today. And I'm going to turn it over to you so you can share with us about diabetes type 2. Treat the root, not the fruit.
Thank you, Dr. Sankey. Good afternoon to everyone. It's my pleasure to be here. I hope that at the end of the presentation that you will have received some information or help on your journey to living well. I know we are quite familiar with different types of diabetes. Type 1, the pancreas does not produce insulin because of probably an autoimmune disorder where the cells, the pancreatic cells, the beta cells have been destroyed, and you have to get exogenous insulin. That means you have to take insulin shots. The type 2 is the most common type, and the individuals have high blood glucose, which can be a result of not enough insulin or insulin not working properly. Then now I found out that I have a 1.5, which is a combination of type 1 and 2. And the type 3, they have DUB, Alzheimer's, because of the function of the brain, which does not take in sugar. We talk about a little bit more. And then the gestational, which occurs during pregnancy. This one's supposed to go away after the baby is born, but sometimes it doesn't. And it puts the individual at risk for diabetes type 2 later in life. I have two slides to talk about Alzheimer's. That the brains of people living with Alzheimer's are in a diabetic state, partly due to the decrease in or insensitivity to insulin. Too much sugar makes the brain toxic. There are similarities in the brains of people living with diabetes and the brains of people living with Alzheimer's. However, diabetes only remains a risk factor. Some people with diabetes may go on to develop dementia, but many will not. Alzheimer's is a specific brain disease which first affects the part of the brain associated with learning. Too much sugar can cause inflammation and insulin resistance. When cells don't use insulin the way they should, that affects the mechanics of the brain. When cells don't get the fuel they need, the brain can't work right. Too much insulin can throw off the balance of chemicals in the brain. These effects on the brain are so strong that some scientists feel that Alzheimer's related to insulin resistance should be called type 3 diabetes. Our body cells are constantly moving food and other supplies along pathways like railroad tracks. There's a protein that is called TAR, which helps these tracks to stay straight. But in a brain with Alzheimer's, the protein TAR gets tangled up. The tracks, they fall apart and cells die because they can't move stuff to where they need it. Some studies suggest that people with diabetes have more tangled TAR in their brains. That could mean they have more dying cells in their brains, which can lead to dementia. This protein, it is believed, is more responsible for causing dementia. Now, when we go to the doctor and we get this diagnosis, sometimes we only go for a routine checkup and it is found out that you have very high sugar levels. What should be done is that they should test your sugar more than once. I guess sometimes they do, but when you're called with the diagnosis and they have to go in, they're going to say to you, take this medication, the first one, which is usually metformin, and then as the time progresses, you may get more until you reach up to insulin. They're going to tell you, change your diet, lose weight. But how are you going to do these things? No instructions given on how these things should be done. No, they're not referring you to like a functional nutritionist or dietitian in most cases. Some may do, but you go home and you have to figure out for yourself, how am I going to get these things done? Insulin is a fat storage hormone, and most people with type 2 diabetes produce plenty of insulin. When the muscles and liver cells are saturated with glucose, it is stored in the fat cells. Obesity and insulin resistance have the same root cause, which is persistently high insulin. Solution for both is to get your insulin down to normal levels. Not a single system in the body is not affected by insulin. That was supposed to be by sugar, glucose. When you have diabetes, a number of systems in your body are affected: your kidneys, your brains, your liver, etc. But it is repairable with the right procedures, which we'll talk about later. From a functional perspective, this looks at the reason for your diabetes, the root cause. Instead of treating the symptoms, you treat the root cause. Cells in the muscle, fat, and liver become resistant to insulin, causing the cells not to take in enough glucose or none at all. The blood glucose and insulin will be high. So if you're resistant to insulin and you're eating, your blood is filled with glucose, your insulin, your pancreas in turn will make insulin to compensate, but they can't do anything. So the insulin will be storing fat in your blood. So as individuals, we need to take control of our lives and decide the way we want to go. Medication will not resolve insulin resistance. The opposite of insulin resistance is insulin sensitivity. So if your body is resisting the insulin, what you have to do is whatever you have to do is to get your body to accept the insulin to become sensitive again to insulin. Persistently high insulin fuels insulin resistance, and persistently low insulin reverses it. Anything that increases blood sugar will increase insulin. Carbohydrates, certain medications like steroids, stress, etc., can cause your blood sugar to go up, and automatically your insulin levels will also go up. We're not programmed to have diabetes. We're not a product of our environment or a victim of our genetics. Even though the genetics may load the gun, the environment around us pulls the trigger. But we can rewrite the tape. There's no gene identified yet that causes diabetes. Even if family members have it, doesn't mean we have to have it. Weight does not cause diabetes, and you don't have to lose weight to get rid of diabetes. Weight loss can be experienced once given proper guidelines. So if you want to rid yourself of whatever chronic condition, it doesn't have to be diabetes, but whatever chronic condition you have to set goals, and you have to be in constant pursuit of your goals. You have to stick with it until you achieve the desired outcome. You have to do comprehensive testing, which is not done a lot. It costs a lot of money, thousands of dollars, and probably insurance may not cover it. So when we do comprehensive testing and we find out what's going on with the individual, then we have to come up with some customized care, because as individuals, we are different, and what will work for you may not work for me. So it has to be an individual care. And you have to be coachable. You have to listen and do whatever your health professional tells you to do. You have to be coachable. So when they do functional medicine lab testing, they use blood or stool, urine, saliva, or hair samples to provide information about a variety of systems, including metabolic, nutritional, endocrine, GI, hormonal, immune, genetic, detoxification, and others. You have to test, don't guess. When you do comprehensive testing and they give you the paper with all the results, it's not 2 pages, it's quite a number of pages, because they even go into your DNA from your mother's side, your father's side, etc., and see if you have a predisposition to anything from your mom or your dad or family members. So the missing link in the diabetes phenomenon is comprehensive testing. This is where detective work is required. Here is where the cause or the causes are identified and removed if possible. Some of them can be removed at this point. You treat the root, not the fruit. We have to turn off the water to the root, which is inflammation, because inflammation causes havoc in our body. And medication won't stop you from making more fruits. It only manages and controls symptoms, because sometimes even though you're taking medication, your condition gets worse. Some people die. Some people have to be put aside on medication, which is supposed to help, but it only manages and controls the symptoms. So here I have my tree with the fruits. We have several different fruits that we see or we feel when we have these chronic conditions. And inflammation is what is driving these symptoms and making your fruits bloom bigger and faster. So let's look at the root. Sometimes when they do the comprehensive testing, they might find out you have toxins. There might be mold or anything in your house, environmental toxin, heavy metals, stress, poor nutrition, trauma, etc. So all these are down underneath, and the comprehensive testing would expose all of these roots, and they can be worked on. So treat the root, not the fruit. So this is an upside down tree. Comprehensive testing leads to comprehensive diagnosing and helps administer individualized or customized care, not one size fits all. As I said before, you must be coachable to take the instructions given so you can get the desired outcome. So I have some labs here that may show up when you do your lab work to let you know that something is really going on. Fasting insulin, the single most important lab. Not all doctors do that. It's typically not included as part of a routine blood work. And they're saying it's partly because of the inconsistency in testing. Some people may have normal range, others may differ. So there's no agreement among experts about what's a normal, low, or high level of fasting insulin. So if you want to know about insulin resistance, test the insulin. And if the body is making insulin, I don't see why you have to take insulin. High insulin levels don't correlate with obesity, but with metabolic health. There are thin, sick people and obese, healthy people. I'm sure you know that. The waist circumference, 40 plus for male, 35 plus for female, does not always end in a diagnosis of insulin resistance, but it's good to trim down the waistline, because underneath that waistline, you have fat that may affect your organs in that area, which is not a good thing. So even if you're not feeling sick, don't have any condition, it's good to trim it down so that nothing can happen in the future. Then we have a C-peptide, indicate that the body is producing a lot of insulin to keep or try to keep blood sugar control. C-peptide is released from the beta cells in the pancreas. It does not actually affect glucose, but it can be measured to figure out how much insulin the body is making and have a normal range. And certain medication for diabetes can cause it to go up. So this is another lab you can test to see if somebody is really insulin resistant. If it's high, I mean, the body is getting insulin. If it's low, low insulin. Then you have uric acid, which is the breakdown of purines from eating meat. And the sugar also increases uric acid. When they're both in the liver, they look alike. The ingestion of fructose causes the release of purines, which turn into uric acid. Uric acid blocks the enzyme in the mitochondria that transports fatty acids to burn for energy, and it has the normal range. The lipid panel, the LDL is least important, but it is focused on more because there's a drug for it. The focus should be on the triglycerides level, because those fats can cause buildup in your arteries. And it is good to look at the pattern over a period. Note the age, the high density lipoprotein to the triglyceride ratio, which is 2 HDL to 1 triglyceride, which is good. And then your A1C and fasting glucose. Medication treats symptoms and not the root cause. And the desired level for that is 5.7%. Then you have eosinophils. These increase. You have parasites, worm, bacteria in the gut, and your homocysteine, and all of these markers here are all part of what comes out on the lab. Vitamin D also is part of that. It acts to reduce inflammation, which is a major process in inducing insulin resistance. Inflammation induces insulin resistance. And if you're deficient in vitamin D, can contribute to both the initial insulin resistance and the subsequent onset of diabetes caused by beta cell death. The labs that are done are the ones that can be medicated. That's what is going on in the world. Some of them can be medicated, so they're not going to do them. So the A1C, when you have high A1C, it makes your cell more fragile. Glucose binding to hemoglobin molecules may result in wrinkles, cataracts, cardiovascular disease, among others. So this process can be slowed down by avoiding sugar. Sugar ages you. Fructose causes glycation to be worse. We'll talk about that some more too. When you do your mean corpuscular hemoglobin, which refers to the amount of hemoglobin in a red blood cell, high or low numbers indicate a vitamin deficiency or certain types of anemia. A1C levels can be affected by anemia. Why? It's a condition where there aren't enough healthy red blood cells to carry adequate oxygen to the body's tissues. And it can influence the results of your A1C test, which measures a person's average level of blood glucose over the past 3 months. So iron deficiency anemia reduces the number of red blood cells, and more glucose molecules stick to fewer hemoglobin molecules. It will make it look as if you have high A1C, when it's not the case. When you treat your anemia, things will go back to normal. There's something called, excuse me, diabetogens, which refers to the chemicals and toxins in the environment that mimic human hormones. These compounds enter our bodies and wreak havoc on our hormonal systems. In the case of diabetes, they cause dysfunction within the pancreas, affecting insulin release and blood sugar control. And then you have BPAs, plastics, and all these things that we use can also have effect on our bodies and cause us to have insulin resistance and other chronic conditions. This picture is a part of a cell that's in our bodies. And this cell has, this cell has organelles, little organs. And the one that we're going to talk about is the mitochondria, which is very important in our bodies. It's small and has so many things. It's amazing. So the mitochondria, that is it. That's how it looks inside. And we're going to talk about it. It has very important purpose in our bodies. It's the powerhouse of the cell. They generate energy from food that the rest of the body can use. If we're talking about one is mitochondria, mitochondrion, and more than one is mitochondria. They have a nucleus and other membrane-bound organelles. They play a surprising role in diet and health since its function in energy production directly influence body metabolism that are also involved in aging and longevity. So the mitochondria is responsible for cellular suicide, which we call apoptosis, cell death, because all dysfunctional cells that have to be removed so that new ones can come in. It has its own DNA. If damaged, it can cause illness such as ADHD, Parkinson's, depression, anxiety, bipolar disease, brain aging, congestive heart failure, diabetes 2, aging, cancer, autoimmune disorders, among others. It provides energy, especially to the prefrontal cortex in particular. Brain cells are loaded with mitochondria, which helps with learning and memory. So when people with Alzheimer's exhibit that they're forgetting, they can't learn, that's because the mitochondria up there is not functioning. Our heart has the most mitochondria, about 5,000. So when we have diabetes, diminished mitochondrial function in pancreatic cells can affect insulin secretion, leading to insulin resistance. In obesity, mitochondrial dysfunction in adipose tissue can disrupt the balance between energy intake and expenditure, thus increasing the risk of obesity. The muscles, the kidneys, the liver, and the brain also have a lot of mitochondria, but it is said the heart has the most because it does quite a bit of work. Mitochondria generate ATP, adenosine triphosphate, that's what that means, through a multi-step chemical process. I would advise you to write down this word mitochondria and in your spare time, read it because it's very fascinating. And you may understand it better if you take your time and read it. So during the production of the ATP, during the production of generating energy, ATP is produced from glucose and oxygen and carbon dioxide waste is produced. So two major processes of this production, which is the Krebs cycle and the oxidative, which is the oxidative phosphorylation, takes place. And it also has another one, which I'm going to show you. All of these take place in the mitochondria to produce energy so that we can feel good and go about our business. The ATP that is produced can be stored in the cell. A healthy cell requires efficient production of ATP to meet its energy needs. And if a cell doesn't get energy, you're not going to have any energy. Glucose and fructose are part of the process in energy production in the mitochondria. Glucose is a big molecule, so it requires insulin or glucose transporters to pass through the cell walls. The insulin takes the glucose to the cell and it acts as a key. The cell opens and it goes in. Once inside, it must be first broken down to pyruvate through a process called glycolysis. And then the pyruvate enters the mitochondria of the cell to go through the process of making energy. Pyruvate oxidation goes through the Krebs cycle, electron transport chain. Fructose goes through the same process if it is accompanied by glucose. If fructose goes in the cell and it doesn't have glucose or fat or something with it, it goes straight to the liver. So it has to be accompanied by something for it to get into the mitochondria. Unlike glucose, which improves fat burning function is metabolized in the liver. Long-term consumption in large amounts can cause the liver to accumulate fat, increasing the risk of fatty liver disease and metabolic syndrome, which is high triglycerides, have hypertension, obesity, cardiovascular disease. It does not require insulin to get into the cell. Fructose by itself is unnecessary in the body. It has no purpose, no biochemical reaction in the body that requires it. 4 things that can damage the mitochondria are fructose, branched chain amino acid, they're saying leucine, isoleucine, and valine, trans fat, and alcohol. And we know all these things are not really good for us. Trans fat, alcohol, fructose, no. So they call these substrates. And so the mitochondria prefers to work with fats and proteins than with glucose, because glucose, fructose, too much can overwhelm the cell and produce a lot of ash. That's what they were saying. When the mitochondria they're overwhelmed with fructose, it can lead to detrimental effects on liver metabolism. Researchers at the Josephine Diabetes Center found that high levels of fructose in the diet inhibit the liver's ability to properly metabolize fat. Isolated fructose is poison to the mitochondria. And then you have your branched chain amino acid. Alcohol permanently alters the communication process in the brain's neurons, and chronic consumption leads to repeated degradation of the mitochondria. Trans fat, the mitochondria can break down the double bond in this fat. This bond was put there by man in a lab. This fat is seen as consumable poison for the liver's mitochondria. There are mitochondrial tests that can be done. One of these is the genetic diagnostic test. And these tests can be challenging due to the complex metabolic pathways of the mitochondria. So the substrate I just talked about, they don't cause a rise in insulin. They're metabolized by the liver, causing it to be overwhelmed. Eventually, they can poison the mitochondria. And we eat a lot of sugar, children are given sugar when they don't behave. They get ice cream and they get lollipops. And one person said children are receiving liver transplants, children are having fatty liver because of the sugar intake. We can only metabolize so much sugar. The mitochondria refuse to take in anymore after a while. And we like to say, I have a sweet tooth. It is believed that this is due to our sugar addiction. And when we say you have a sweet tooth, we think it's okay and it's accepted. So if your mitochondria is working good, it will reduce the risk of chronic diseases and vice versa. There are no medication yet that make it to the mitochondria. So it cannot be medicated. It needs real foods to fix it when it is damaged. So this is our glucose. It's big. It has carbon, hydrogen, and oxygen. So it has to be broken down for it to get into, it can go into the cell, but not into the mitochondria in this big state. So it has to be broken down. And this is how it is done. You have glucose and it's broken down to 2-pyruvate. And this is the Krebs cycle. I think this is the second area where it goes to reach its destination. You have a series of chemical reactions help generate energy from the foods we eat. This is the electron transport chain. Electrons are transported down the line to reach the end so we can get energy from the food we eat. So all these pathways work together to extract energy from glucose, ensuring our cells have the fuel they need for various processes. So dietary strategies to support mitochondrial health. We have to make good choices. Limiting the consumption of highly processed foods. Food has to be processed, some of them for us to eat. No doubt about that. But when they're so highly processed, we can't process our food in our kitchen, somebody said. So when it comes from the factory, it is highly processed. So we need to eat more legumes, fruits, nuts, seeds, high fiber foods, and unsaturated fats, avocado, salmon, olive oil, adequate protein intake and consumption of micronutrients such as vitamin C, B, and magnesium. These are all vital to help our mitochondria to be healthy. So exercise also, high intensity exercise generates mitochondria. So it's not just diet, you have to put exercise with it to help the mitochondria. It makes new ones. They have intermittent fasting where you cycle between periods of eating, and you have to choose how you want to do that. You have different ways to do that. Occasional detox. The choice is yours. I just see my computer dim, so maybe it needs to be charged. Maybe I have to move a little. So we can only metabolize so much sugar. The mitochondria refuse to take any more after a while. It gets overwhelmed. So it refuses to take any more after a while. Sorry about that. So a good work in mitochondria will greatly reduce the risk of chronic diseases. There are no medication, as I said, to fix it. Only real food can fix it when it is damaged. And I have a chart here that shows you the effect of the different foods on your sugar levels over the hours. So the highest one, that's the carbohydrate. That's how it affects your blood sugar. It spikes and then comes down fast. Protein is the purple, and it goes over a long period of time, and you have your fat. So when you have these three together, it helps your blood sugar levels, because the fat will keep you full longer. Fat and protein with the carbohydrate will keep you full longer. So our carbohydrates are chains of sugar molecules. Whether they taste sweet or not, they have sugar. But from a blood sugar perspective, not all carbohydrates, calories are created equal. So it is advised that we avoid naked carbs. Don't just eat oatmeal with milk and a banana. That's naked carbs. Add protein or fat, because these two nutrients act as a buffer for carbs. Carbs enter the bloodstream quicker, so fat and protein slow down their entrance. Blood sugar control needs fat and protein and low carbs. Initially, I said that initially. So if a meal increases insulin levels by more than 30 points, that meal should be examined and find the culprit. That's why it's good to have diabetes and trying to control your sugar levels. You write down what you eat, what your sugar level is before you eat, and after. So taking medication for diabetes too is like throwing gasoline on the fire. It makes the problem worse. Medication is not going to help get rid of your diabetes. Diabetes is a progressive disease if you don't take the steps to stop it. You usually get your blood sugar medicine, blood pressure, statin drugs, because the medical world knows that this is a progressive disease and diabetes will cause other chronic conditions to show up. So you get the whole work because they know what's going to happen. There needs to be a diet and lifestyle shift. Don't do the same thing over and over and expect different results. That's madness. So type 2 is preventable, treatable, and reversible. Avoid naked carbs, as I said before. Add protein and fat to act as buffers. Limit or avoid starchy foods until blood sugar is normalized. These can be added back gradually in small portions. Initially, no grains. And there's a big consensus on this. No grains. No flour, pasta, rice, corn, etc. So what's recommended and what I do, sometimes I eat 3 non-starchy vegetables and 1 to 2 animal protein for non-vegan. And the vegans can use their tofu, tempeh, mushrooms, spirulina, nuts, seeds, pea protein, etc. to go along with their meal. It's easy to overdo it on the carbs on a vegan diet because a lot of beans are eaten on a vegan diet, and beans have more starch than protein. So initially, you leave the beans, or if you're going to eat beans, small amount with something. You don't have to eat less, just eat the right foods. Eat real foods. And I give an example, 2 proteins plus 3 vegetables, 1 fat. If some person may really need the starch, so just about a half cup if you really need it. So you check your sugar after you finish eating and see the difference in the numbers before and after your meal. Your blood sugar levels will not skyrocket unless something is really, really wrong inside. Snacking between meals may keep insulin and sugar levels high. So if you're trying to keep your insulin down and you eat your breakfast, 8:30, and probably 11, you go eat something else with sugar or whatever, it's gonna keep your insulin levels high all the time. So we don't want that. So you must know your body. If you really need to eat something, you must know how you feel when your sugar is low and also when they are high. So I have here breakfast, 1 or 2 protein. I eat lots of avocado. You can have a couple slices of avocado, 2-3 slices. It's a good fat. Lettuce, tomato, cucumber. And if you want a starch per se, I like Ezekiel bread because it's friendlier towards people with diabetes because it is not processed into flour. So the sugar content in there is low. If you want some tea, you can sweeten it with monk fruit or another appropriate sweetener. No honey, maple syrup, coconut sugar, or syrup. Leave those for later when your sugar is under control. For your lunch, you can have protein, carrots, broccoli, cauliflower, avocado. A small slice of sweet potato can be added if needed at this point. For supper, you can have like 1/3 cup berries with unsweetened yogurt, full fat, no low fat, because we need the fat to act as a buffer. You can have a salad with cubes of protein, avocado, chickpeas, this kind of stuff. And if you want a beverage, you can drink sparkling water, unsweetened tea. If you drink coffee, decaf, unsweetened, or you can sweeten it with the monk fruit. Anything that increases blood sugar increases insulin. Each case is treated individually. Don't stop taking your meds until you talk with your doctor, because he has to know what you're doing. Carry your numbers to him, tell him what you're doing, and he is supposed, if you see good results, he's supposed to gradually reduce your medication until you come off of it. You can get in touch with a functional medicine practitioner for extra help. Pray for God's guidance throughout this time and beyond. And one of my favorite texts is Psalms 139, which says, "You're fearfully and wonderfully made." So this is the end of the presentation. I hope that it wasn't over your head. I understood what they're talking about, and you can get help if you need further help. So thank you for your time.
Josephine, thank you so much for sharing such an insightful presentation on diabetes type 2, on the mitochondria, Alzheimer's. What I found interesting is when you mentioned that obesity is not the cause of diabetes. So a lot of times people try to link different things together, but really understanding the mitochondria and what it needs really provided a broader insight on why the body does what it does, why it's important to maintain a healthy diet. And I'm glad that you shared that last slide that had all of those meal options, examples of what we can eat, and why it's important to eat carbohydrates, fats, and protein together, because of the different times that they're eliminated from the body or that they stay within the body. So I thought that was very insightful. We can open it up for questions if anyone has a question for Josephine.
Yes, Josephine. First of all, that was a wonderful presentation. And yes, some of it was above my pay grade. But a couple of things. I didn't know that Alzheimer's and diabetes were related. I didn't know that. And also, can you give me a little bit more insight on cataracts as it relates to diabetes?
You know, when your blood sugar is high, it damages the blood vessels in your eye. I'm not saying I know exactly how it forms, but you have eye issues. People go blind from diabetes because of the constant high sugar affecting the blood vessels in your eye. So people can develop cataract, glaucoma, and all these things from diabetes.
Did that answer your question, Stan?
I don't know the fine details, but that's what I read, and I know diabetes can cause blindness.
Yes, that was very insightful. Thank you.
Diabetes can cause blindness, so yeah.
Any other questions?
Yeah, Josephine, that was very informative. Thank you for all the hard work you put into that research to bring such a inspiring topic that's well needed for our platform. Thank you so much. Now, checking the blood sugars after eating. How soon after eating we need to check our blood sugars? And you said it needs to be less than 30 points.
If a meal raises your blood sugar more than 30 points from the beginning, so if your blood sugar is 110 before you eat, and it goes to like 160 and all that, that means something you ate took your blood sugar up there.
Right.
It's supposed to be about 140. So if it goes beyond that, you have to look at it.
Right. So we do it immediately after we eat.
No, 1.5 to 2 hours.
Okay.
You
Okay,
cannot
that's what I
wait
wanted.
too long because after a while your blood sugar starts to come down again.
Yeah.
So you have to time it to get that good reading.
Right. So 1.5 to 2 hours, you said?
Yes.
Okay.
So for Stan,
Okay.
give me a minute. It says as you age, the lenses of your eyes become less flexible, less transparent, and thicker. When you have diabetes, high blood sugar levels over time can lead to structural changes in the lens of the eye that can accelerate the development of cataracts.
Okay.
Yeah, cataracts. Yeah.
Jocelyn, I see your hand. Joycelyn? Love to hear your question. Joycelyn?
I was muted, sorry.
Okay.
Thank you so much, Josephine, for your presentation.
You're
There
welcome.
are two things I want to ask you. You kept mentioning buffering. Can you explain a little bit more by what you mean by buffering?
Okay.
And then the other one was, you said when people eat beans, they need to eat it with something else like
yeah, I know. I said that needed some explanation in my mind. Buffering, if you just eat an apple or some oatmeal, within an hour and a half or so, you're going to be hungry. Okay? So if you eat your oatmeal, if I eat oatmeal, I put peanut butter in it. It sounds gross, but I like it. It tastes good. Peanut butter is a fat. So you can eat your oatmeal with a protein, a slice of avocado. Because as I showed you on the chart, that eating carbohydrates alone, you're going to be hungry quick. But when you add the protein and the fat, it takes you longer, like 5 hours. So it buffers, it keeps the food in your stomach because fat and protein are complex structures and they're not easily broken down like carbohydrates. So this in your stomach with the carbohydrates a little longer, so you won't get hungry. That's buffering.
So if I were to add maybe some coconut cream or butter to the oatmeal when I make it, would that count?
That too, you can put coconut oil in your oatmeal. You can put butter in your oatmeal. That would count.
Okay, thank you.
And what's the other one? Yes, if you eat beans, what I would suggest, I like mushrooms, and I eat mushrooms with spinach. I sauteed them and eat them. You can put some, maybe, instead of eating a lot of beans, have a small amount, mix it, stew it down together, probably with some spinach or mushroom, carrots, whatever. You can make whatever you want. But as I said, beans have more carbohydrates, more starch than protein. So if you eat too much and you're trying to get your sugar levels under control, it can give a negative feedback. So don't eat too much of the bean. Eat a small portion and mix it with other stuff. You can try it on your salad then. Just some of it on your salad, that beans or whatever on your salad. But you have to know what the beans will do to your sugar by testing your sugar before you eat and 1.5 to 2 hours after you eat. So if you know if that beans did anything drastic to your sugar levels.
It's also an old adage that you can help me with this because you're a dietitian. 2 second-class proteins make a first class. So if I'm combining the beans, can I use a small portion of beans, maybe with some quinoa or some rice, and add it to the salad?
You can do that later, but most of what I'm saying is geared towards people who have very bad high sugar levels. Okay. And they need to get it under control. When you do get it under control and you're off your medication, etc., you can gradually add small portions of starch back to your diet. But don't overdo it, because if you go back to where you were, you can get the same problem. Diabetes can come back. You have to know when they're under control, eat, your lifestyle should be such that it won't come back. So if you know that starch is a main culprit in raising sugar levels, you limit that. That should be limited. You eat more of the foods that won't raise your sugar, protein, fats, and your non-starchy vegetables, and you can add small portions of starch to it.
Okay. Thank you very much.
You're welcome.
I had a question, Josephine.
Okay.
You were saying, well, I have a couple of questions. The first one is, you said try to find a functional medicine provider. Do you have any suggestions on where to begin to find that information out?
Yeah, I can give you some ideas. There are a number of them on that I listen to that can help, but the only problem with them that you have to, I don't know any locally. I don't know if anybody knows anybody locally, but they have a program where you can join, but it costs a few dollars. There's one lady called Mallory Nowak, Dr. Shumad, Dr. Living Good. These have lifestyle programs that you can join and get good results, because there have been lots of testimonies. And I believe in what they're saying because it makes sense. So you can go online and Google functional nutrition if you want any in Orlando or in Florida. But off the top of my head, I can't tell you anybody. But I've done a course in functional nutrition. So I am willing also to help. But these people have more training than me and they're more experienced. So I can talk to you about your labs, etc. I still have some to learn, but I try to help as many people as I can with the little knowledge I have.
Okay. And also, I was gonna ask. I haven't been diagnosed. I know somebody have. If they're diagnosed with, I guess, borderline diabetes, and they're being treated with metformin.
If you're borderline, you shouldn't be getting any metformin. My doctor told me I was borderline. I was having trouble with my A1C. It was 6.2, and that was alarming. It's now down to 5.9 because I'm trying to incorporate what I learned to help it get down there. So eating less of the starchy foods will help. Small portions with your protein and fat, etc., can help.
Okay, thank you.
You're welcome.
I see your hand, Alicia.
Yes, I like to put chia seeds and flaxseed in the oatmeal. Is that okay?
Yeah, chia seed can be eaten just like that, you know. It can be eaten as a pudding. You can make chia seed pudding, and you can put your flaxseed in there. And you can eat it as a cereal. I do that sometimes. Eat it, make it, put it in the fridge, and it's come like a jelly. And I can eat that with maybe a protein. Because chia seed is protein, but you can eat another protein if you want. Avocado. I don't eat oatmeal a lot because it's a grain. If I eat oatmeal, it's a sprouted oatmeal I will cook. Not the regular 1 minute old-fashioned thing.
Well, I know about the steel cut and the rolled oats, but the steel cut now, I have to be cooked to be eaten.
As I said, Alicia, when you're going to eat, you test your sugar and see what it is. You eat what you have to eat, and an hour and a half to 2 hours after, you test it again and see what the food did with the sugar levels. Because they're saying it's not supposed to be above 180 for people with diabetes and 130 for non-diabetics. But it's good to keep your sugar levels under control. So if the food carry it up, you either decrease the amount that you eat or you leave it off altogether.
Okay.
Emma, I see your hand.
Yeah, I just remember Josephine made a comment, not to eat grains. Is it because of the highly GMO or the high gluten content in it? And if we eat sprouted grain, is that better than just the simple,
Organic
you know,
sprouted grain, because it's not highly processed like the other grains. Example is the Ezekiel bread. It has not been turned to flour because it was not processed to that extent. So it's, if you look at it, you find seeds and everything falling out of it when you're eating it. So I like Ezekiel bread for that. I don't really eat the regular bread, often once in a while. So, and the grains too, if they're not organic, they have a lot of chemicals and such things on them that can make you sick. The Roundup chemical and all that.
Okay. Let's see. Any more questions for Josephine? I found this very interesting, Josephine. You know, we think we know about diabetes, we think we know about our bodies, but many times we don't think about it from the cellular level.
It's a cellular condition.
Right, and how it affects, even how it affects the other organs of the body. And so I'm glad that you included that now Alzheimer's is being looked at as part of, it's not diabetes, but it's a type 3 that they're claiming it to be. And so I think the more knowledge we have, we can take precautions preventive, take action to prevent it from happening. And if it has happened, get to the root cause and understand, what is it? What is it? Is it something I'm eating? You mentioned the fructose, the trans fats, all of those things that are really not good for the liver at all, not good for the body, and sometimes we just need to step back, read the label of what we're eating. So thank you so much for sharing that.
You're welcome.
I don't see any other hands. I don't see any other
You know
questions.
something, I was trying to put my hand down and I'm not sure if I put someone else's hand down. So make sure there's no one else.
I
with a
don't see
question.
anyone's hand. I do not. If there's anyone else, speak up, because we're getting ready to take prayer requests. Josephine, thank you so much again for your research. We do thank God that you have such a passion and a love for sharing knowledge. Man, Emlyn, we always are so happy when you bring forth a topic that maybe we didn't think of, or one that you have studied and you want to share your knowledge. Just want to say thank you for that.
Yes, you're welcome.